Okay, so when we do the review here, let me go ahead trying to see if I open this one so I can write. Okay, the first one right here is you want to write this interval as an inequality or double inequality, or sometimes vice versa, you're gonna write down the inequality into the interval. So basically you need to know what is on the interval in here, okay? So in order to do the interval, let me giving you okay, let me see. Um I'm trying to see where's my drop one. Okay, my drop button is not in here. Okay, let me go ahead open another one. Okay, I think I didn't have a draw button in my Microsoft Word. I think I just got this new laptop um not long ago, so it probably still didn't. I haven't customized it or set up there. So I just go ahead using this one. This one has a draw button. Okay, so it won't take a little bit time to set up that one. Just go ahead using this one. All right. Okay, so the first one right here. Okay, so we have okay, we have 4 and 6. So 6 with the bracket, right? So when you have a 6 with bracket, this means okay, I'm gonna drop a number line in here. So this is X, right? And this is 4, this is 6. Okay. So what does that mean here is that means X is greater than 4, okay? Greater than 4 and less than, all right, so greater than 4, but less than or equal to 6. When you have a bracket, that means it has an equal sign in here. Okay. When you don't have an equal sign, you're using the parentheses. So that means this X here will be greater than 4. All right. But less than or equal to 6. That's what I mean in here. Okay. So if you write this one, if you using the if you use the separate inequality, right? If you want to separate into two inequality, you're gonna have a X is greater than 4, okay? And you're gonna need to use N because this is a compound called a compound inequality, right? So X is greater than 4 at the same time. All right. Okay. Okay, X is greater than 4, and also X is less than or equal to 6. Okay, so if you want to write down into two inequality, the simple inequality, you're gonna have to use the N in here. Okay, so N, that means you have to satisfy both at the same time. All right, otherwise, if just only X greater than 4, what does that mean? That means if only X greater than 4, it will be from here all the way to the right. Okay, and if you only have X is less than or equal to 6, this will be 6 right here, right? And then you're gonna be from here and then go all the way to the left. All right, so that is the single inequality. But the compound N, that means you have to have both at the same time. So that means X is only between 4 and 6. Okay. All right, so the second one right here is if I want to write down if I want to write down x greater than 1, less than 2, okay, what happened? What is the interval notation? Well, since this don't have a equal sign, so you're gonna have both using the interval. You're gonna use both using the parentheses. Okay, so this is called an open interval in here. All right, so between 1 and 2, but did not include 1 and 2. All right, but if you have an x greater than or equal to 3, but less than or equal to 4, right? So we always write down the smaller number on the left. So this will be from 3 to 4, and both with bracket because they both has an equal sign. Okay, so that's called the interval notation. That's called the interval notation in here. All right, so you only have 3 different type of the interval. Okay, all right. So if you only have like I say, if you only have an x greater than 5, and don't have another number on this side, what happened? All right, so greater than 5, you're gonna use the parenthesis, and then this is gonna go all the way to infinity, right? So you're gonna have a 5 with the minimum, okay, the smaller number. And then this one, you're gonna go to the infinity. So using the label 8, that's represent the infinity. Okay, and infinity you never ever equal to. So infinity is always using the parenthesis. All right. And then if you have an x less than or equal to -2, right? So if I have an x is less than or equal to -2, how do I write down in my interval notation? So this one, less than or equal to, so that means go this way all the way to the left, right? So what's my smaller number? My smaller number here will be -infinity. Okay, and then using the common, and then the -2 would be my maximum. Okay, all right. So since this one has an equal sign, so you complete with the this bracket, that one. So basically, this is one situation, right? Greater than. Second one is less than. Okay, and then go all the way to the left. This one go all the way to the left. The one we talk here, these are all similar, right? This is between 2 numbers. Okay, so between 2 numbers, you just write down smaller number on the left, large number on the right. Okay, and if you have an equal sign, you use the bracket. Okay, if you have an equal sign, you use the bracket. If you do not have an equal sign, you use the parenthesis. All right, so that is the interval notation. Okay, so we basically just review all the interval notation. Any questions? If you have any question, you can go ahead and ask. Okay, so I don't mind interrupt because this will be the review, and I want you to go ahead ask any question you have. Okay, when you go through this one, because this will be similar to your test later on. Okay, the second one here is solving the solution, find a solution set, right? So basically, this is called inequality. Inequality with a fraction. So sometimes we do not like a fraction most of the time, right? If you like a fraction, that's fun. If you do not like a fraction, that's okay. You can get rid of the fraction. Okay, so how do you get rid of fraction? You can multiply this common denominator. Okay, and I was showing you both ways to see how you do with the fraction, how do you do without a fraction. All right, so the fraction here we call the LCD, the least common denominator, right? And since 4 and 5, they don't have a common factor, so my least common denominator here will be 4 times 5 or 20 in here. Okay, so if I multiply both sides by 20, the denominator will be all gone. Okay, all right, so let's do this one. So you have a 20 times left-hand side, right? M over 4 minus 4. And then you also need to multiply the right-hand side, okay? Multiply with the same number, of course. And since the number I multiply is a positive number, so I don't change the inequality direction. So basically, you do the inequality is very similar like an equation, okay? The only thing difference here for the inequality is if you divide by or multiply a negative number, you have to change this inequality direction. That's the only difference. Otherwise, if I change this into equal sign, the solution, the method will be pretty much similar. Okay. All right, so now we're gonna distribute it in, right? Distribute this one to the first one. You also need to distribute this one to the second one. Okay. When I distribute to the first one, 4 and 20 cancel out. So this will be 5. Okay. And 5 times n will be 5m. So this will be 5m. The second one, I don't have a 4 in the denominator, so I will need to distribute 20 to the 4. So 20 times 4 will be 80. Okay. And then similar to this one right here, this 4 times 20 divided by 4 will be 5, right? And 5 will need to times 7, so that's 35. Okay, and then the second one, when I distribute a 20 in with the second one here, the second one is 5, so 20 divided by 5, we actually get 4. So this 4 need to multiply the m, so the minus 4m in here. Okay. All right, so now we're gonna move all the variable into the left-hand side, move all the number to the right-hand side. So in this case, you're gonna get rid of this 4m on the right-hand side, right? And when you do something to the right, you also need to do the same thing on the left. Okay, so need to be fair to everyone. All right, so I add a 4m on the left-hand side. I also need to add this on the right-hand side, right? So these two gonna be canceled out. So this is gone, right? And then this 5m plus 4m, this will be 9m. All right, and I also need to get rid of this 80 on the left-hand side. So this is minus 80. So in order to get rid of this one, I have to plus 80. And remember, we have to do the same thing on both sides. All right, so we call this is kind of need to be treat everyone the same, right? So this cancel out, all right? And then we have a 35 plus 80, so that's 115. Okay, and then we have we want to solve 1m, so I still have a 9m here, so I divide by both sides by 9. All right, so this cancel out. So my m here will be less than 115 over 9, right? And we usually trying to see if we can simplify this one or not. So if they have a common factor, you have to simplify. So this one, 9 can be divided by 3, but this one you cannot divide by 3 on the numerator. So if not, this is the final solution, right? And we also need to look at the requirement in here. You cannot just write down m less than 115 over 9, right? So look at this one right here. It said use the simplify your answer, right? Which we already did. We don't have a common factor, so we don't need to simplify. Use the integer or fraction for any number in the expression. So that means I want to keep this fraction. I don't want to change this one into decimal point. Okay, so do not use the calculator to divide this one into decimal point. You either keep the integer, which we don't have an integer here. So if not, you're gonna keep the simplified fraction, right? And this one you cannot simplify, so that's the final answer. But you do need to keep the fraction, all right? And also need to type your answer in the interval notation. Okay, so what is the interval notation? Basically, in a lot of time in the college level math, they require the interval notation. So this is the interval notation we have earlier, remember? All right, and this one is less than. Okay, you can give it a little bit of quick dropping to see how this look like. Okay, so less than is going to the left-hand side. All right, so 115 over 9. All right, so that means this go all the way to the left. I don't have a minimum in here, so my minimum will be negative infinity. All right, interval always need to have a 2 number, a smaller number on the left, large number on the right. Okay, and less than, that means my smaller number will be negative infinity. All right, and then my maximum here, or my large number here is 115 over 9, and use the parenthesis because this doesn't have an equal sign. Okay, So this is your final solution in the interval notation. All right, not this one. If you type this one, even you do everything right, but you don't type it in the correct format, the MATLAB method still counter you wrong. Okay, and of course I usually for the test I don't correct the homework assignment, but I do correct your test assignment. If you don't write down the interval notation, but you got this one, I still giving you the partial credit. Okay, instead of the automatically giving you 0 from the MATLAB math, I will check everyone's test. So after the due date, and then you will receive the partial credit. You still won't be able to see the full credit because you don't write down the interval notation. Okay, but you will get a partial credit for this one. Okay, any questions? So that is get rid of denominator, right? Some people say, I like a fraction. I don't want to get rid of the denominator. You can do without getting rid of the denominator in here, okay? So pretty much is similar. This one, I have a m over 4, right? And I want to add a m over 5 on both sides. So add a m over 5 on both sides, okay? And this will be gone. And I will less than 7 over 4, right? And then this, you have a minus 4, so I need to plus 4 on both sides, okay? So I just kind of plus 4 on both sides, this will be gone, right? So right-hand side, I need to plus 5. I plus m over 5 on both sides, so this will be gone, right? But right-hand side, left-hand side, you have to have this one. Okay, so now you will need to add these two together. So in here, you still need a LCD. Okay, your LCD here will be 20. Okay, so in order to add these two together, you need to have a least common denominator. All right, so in order to get this one to 20, this need to times 5 over 5. Okay, so 4 times 5, you got 20, right? 5 times m, you got 5m. Okay, so that's for the first one. The second one, in order to get a denominator to 20, you need to times 4 over 4. So 4 over 4 basically is multiplied by 1, right? Anything times 1 still equal to itself. All right, but we need to transform. So this will be 20, this will be 4m. Okay, and then this one right here, in order to add these two together, you're gonna change this one into denominator into 4, right? So you can times 4 over 4. So this one right here, 4 times 4 is 16. Now you can add. All right. So when you have a fraction, when you have a same denominator, you just need to add a numerator, right? So this 5m plus 4m, you got 9m. Okay. And then this one, you have a same denominator. You have a 7 plus 16, you got 23. Okay. All right. So now how do I solve my m here? Solve for m here, you need to multiply the reciprocal of this one, right? So this is 9 over 20. I need to times 20 over 9. And same thing, you need to times 20 over 9, times the same number on both sides. Okay, so now 20 cancel out, m and 9 cancel out, so you have an m. All right, and this one you don't need to simplify. Okay, so this one you have a 4 and 20, you can simplify. So this will be 5, right? And then you have a denominator is 9. Now 23 times 5, you have a 15, 10, 11. All right, so you got exactly the same answer as we did in here. Look at that. You got this one right here. You got this one, same answer. Okay. So which one do you prefer? The first one or the second one? The first one here is actually a lot of people actually probably prefer the first one, right? You get rid of all the denominator at once. Okay. So the second one here, you have to find a LCD, and then you need to find a LCD on both sides, and then you have to multiply the reciprocal in order to solve for m in here. Okay, So both way, either way will work, but in my personal opinion, the first way would be a little bit easier. What do you think? Take a vote. How many of you prefer the first one? Type 1 if you prefer the first one. Or type 2 if you prefer the second one. Just kind of quick. Anyone? The first method or the second method? Okay, right. So I think, yeah, I think that is about right. A lot of people prefer the first one. And I think, in my personal opinion, the first one is faster. Even I write down a little bit more, but I think the first one is a little bit faster. Okay, so you can just only need to focus on in one method. You don't have to do two methods at the same time, okay? As long as you do one method well, you can just stick with that method, all right? Okay, so let's move on to the,
Don't you know the volume is off? Like, what the hell?
please mute
Bro, this the shit
yourself.
I'm talking about.
Yeah, mute yourself until you want to talk, okay? If you have any question you want to talk, you can unmute yourself. Otherwise, just go ahead and mute yourself so we can hear a little bit clearly. All right. This is a review for the test. Yeah, so we want to put it pretty clearly that way, knowing, you might want to review this one later on as well. Okay. So find the equation for the line with the intercept, y-intercept as -6 and the slope as -3/5. So you need to write down the equation of the line in a slope-intercept form. Okay, so when we're trying to write down the equation, okay, for the linear equation, we have two different ways to do it. Okay, one way here is we have a y equal to mx plus b, and that is the formula you will need to learn in this section. All right, let's call it a linear equation. Okay, and the m here is the slope. The b here is called the y-intercept. All right, so this one is already telling you everything. Okay, so you stop here. That means this whole thing is m. All right, so I will write down y equal to m. M here is -3/5. Okay, and remember you need to have an x. All right, and the y-intercept is -6, so just -6. That's it. That's the whole thing. Okay, enter the equation in a slope-intercept form, and that is called a slope-intercept form. Okay. And if you want to know how this one look like, you can actually use the calculator to graph. Okay, we do allow you to use the TI-83 or 84 calculator. Actually, basically in this college algebra and business math, I actually allow you to use any calculator. Okay, but only the graphing calculator can graph. So let me show you a little bit how to use the calculator. Okay. All right, I'm gonna using the trial version for now. I will go to find out the license number. Or you can using the smaller calculator, which is free. Okay, this one is a little bit bigger, but you can also download some of the free calculator. But if you have a handset, that's even better, right? So I have this one right here, and then go to the y -3/5x. So -3/5x, okay, minus 6. And then I hit enter, I will hit graph. So that's how the graph look like, right? And then you can actually zoom a little bit, or you can make this a little bit bigger. Okay, go to the window, make it a little bit bigger. That one. All right, so that way you can see a little bit entire thing in here. Okay, and the good thing with the graphing calculator, you can also look at a table right here. All right, so if you go to second graph, we'll be look at a table. So you can see when x equal to 0, y will be -6, right? And then you can also go all the way up to see whatever the x value, you can find the y value, or you can plug this whole thing into the calculation, right? So for example, I want to calculate when x equal to, say, equal to 10, right? And how much is y? Okay, so I want to calculate this one. Okay, so I will plug it in -3 over 5 times 10, right? So this x will be 10 minus 6, right? And 5 and 10 cancel out. You got a 2 in here. So 2 times -3 will be -6. And then you also have a -6 right here. So what does that mean here is when x equal to 10, y gonna be -12. Okay, but if you do not want to calculate this one by hand, you can come back to the table to look at it. So we can go to find go all the way down here when x equal to 10, right? So we can go in here. Oh yeah, when x equal to 10, y is -12, right? So we just calculate when x equal to 10, y is -12. So if you do not want to calculate this manually, yeah, you can use the calculator. Is, will be pretty much in here. All right. So this graphing calculator, you have 3 things in here. Look at it. If I only type 8, if I put 8, it will show the 8. If I use the second, which is the blue color, second 8, I will get a V because it triggered the blue one. And if I use the alpha A, I will get a P in here. So if you want to access the blue color, you have to hit second first, right? And then if you want to access the green color, let's see, I want a W in here. So W is under the green color. So I need to hit alpha minus so I can get a W. But if I want to get this bracket in here, I will have to use the second in here. Look at it. Okay, so that is just giving you a little bit function of the calculator. But if you want to do the graphing, you will have to, input y equal to x value, right? And later on, if we then a quadratic y equal to x squared, okay, so that's how you look at it. All right, and then you hit graph. So that's y equal to x squared look like. Okay, and then if you hit second graph, you can go through all the table. All right, so now you can see when x equal to 2, y2 will be 4, right? Since y2 is equal to x squared. So 2 squared will be 4, 3 squared will be 9 right here. All right, and then you can go up and down in here. You can go up and down for the x and y value, okay? All right, so yeah, graphing calculator will be pretty helpful in here. Okay, so that's showing you a little bit of graphing calculator, which is pretty helpful. Okay, so that is the slope intercept, okay? And we want to indicate, so the chapter 2 is about function, okay? So what qualified to be a function in here? That's a concept. So in order to qualify to be a function here is one input can only have one output. Okay, one input usually is the x value, and output we usually say is a y value. So if you have a one x only have a one y, that is considered a function. Okay, so this using the domain, x usually is the domain. Okay, and y we usually call it is a range. Okay, y value is the range. So look at one input only have one output. So is this a function or not? Is this table a function or not? According to the concept, everyone, yes or no? All right, how about type of the chat, or you can unmute yourself, give me a little bit of answer. Is this a function or not, according to our concept? In order to be a function, one input can only have one output. So does this one qualify a function? Okay, anyone, yes or no? Okay, don't be shy. The answer will be no. Okay, why this one is not a function? Because look at the number 19 in negative 19 in here. This negative 19, what happened? One input, you got two output in here. So you have a negative 19 corresponding to negative 10 and 8. So this one will be, answer will be B. It's not a function. Okay, because the concept here is in order to be a function, one input can only have one output. So this one, negative 19, has two outputs. So the answer will be no. Okay. The opposite one will be true if I have a 1, 2, and 3, and this will be 9. Okay. And everyone corresponding to 9, what happened? Is this a function or not? Well, according to the concept, actually, the one I draw for this table will be a function. Okay, why this one is a function? Because even they have a same output, but the input, each one only have a one output. Look at it. One only have a one output, 9. 2 also have a one output, 9. 3 also just have a one output. They just happen to be the same. Okay, but each input only has a one output, so that is considered a function. So this one is not a function because negative 19 has a two output. So that's why the function, you have to know the function. On the table, we say using the one input, one output. On the graph, if we don't have a table, we have a graph, we use called pass the vertical non-test. Okay, so what is the vertical non-test in here? Let me show you this kind of graph. All right, if I have this graph and then I drop a vertical non anywhere, okay, and it's only past one point. All right, and it only cross one point, so this one will be a function. Yes, this will be a function because it does pass the vertical non-test. Okay, so I drop a vertical, that means one input only have a one output. But if I drop the graph the other way, or like I say, a circle, okay, and what happened? If I drop a vertical line, this is gonna pass 2 points on the graph. So this one will be not a function because 1x value corresponding to 2y. You can see this 1x have a 2y. So this one is not a function. All right. Or we call did not pass the vertical non-test. So I drop a vertical non, it passed 2 points. So it's not a function. Okay. So from the graph, you drop a vertical non. From the table, you look at one input, only one output. All right. So that is the concept for the chapter 2, because chapter 2, we all learning about function. Okay, number 5, find and simplify the expression in here. Okay, so we learn the function notation for the chapter 2. So we using f instead of the y, right? So if I have a y equal to x plus 1, that's the equation, right? And I can write down this whole thing into a function notation using f of x. Okay, so f equal to x plus 1 in here. That means f of x is exactly equal to y. But why we use the function notation? Because if I want you to find the x equal to 3, right? How much is y? I have to write down the whole sentence in here, say, please find the y value on x equal to 3. But in a function notation, I don't have to have a statement in here. I just using this symbol, f of 3. So, and f of x equal to this one right here, right? So now I will need to be able to replace x by 3 in here. So that will be 3 plus 1, which is equal to 4. So f of the 3 will be 4. Okay, so this is much easier to express. So this also have a pair. X is 3, Y is 4. So this is the order pair. All right, so how do I find this one right here, number 5? Okay, so for this number 5, my f of x is equal to x squared plus minus 6. So how much is my f of 3? Well, f of the 3, replace x by 3. So this will be 3 squared, okay, minus 6. And 3 squared is 9. 9 minus 6 will be 3. Okay, and how much is my f of h? Well, my f of h, I just replace x by h. This x is a variable, can be changed by anything inside the parenthesis. So my parenthesis here is h. So this x will become h. So this will be h squared minus 6. Okay. All right. So you find this one and then just add these two together, right? So you want to have an f of 3, f of the 3 plus f of h, right? Okay, so how much is my f of 3? My f of 3 is 3, right? And then my f of h is h squared minus 6. Okay, and you always need to combine the like item or simplify the final answer. So these two are the like term, right? So you need to add these two together. So my final answer here will be h squared 3 minus 6 will be negative 3. So this is my final answer in here, h squared minus 3. Okay, so that is called a function notation. Any questions? All right, number 6 is graphing this function. Okay, so this function basically got a two pieces together. All right, I think for some reason my answer C here got chopped. One function did not print that up, but that's okay. We can graph this one on our own in here. Okay. This is called a piecewise function. So why they call it piecewise? Because x for the first function, x is only less than 1. Okay. For the second function, x can only be greater than or equal to 1. So that means you have to put it into two graphs and then combine them together. Okay. All right. So let's see how do we graph this one. The first one right here, you have to choose 2 points, right? So we usually need 2 points to graph a line. Okay. I can choose x equal to 1. Or if you don't want to calculate by hand, as I showed you that earlier, you can do that in a calculator. Okay. But the first one right here is x, and then this is y. Y here is 1 minus 2x, right? And x had to be less than 1. Okay, and I can actually choose 1 in here because I just don't want to graph this one into a solid one. I'm using a circle for this one because there's no equal sign. Okay, so when x equal to 1, 1 minus 2 will be negative 1, and you cannot choose 2 because 2 will be not less than 1, but you can choose 0, right? So when x is 0, this will be 1. So this is enough to graph. Look at that. I only need 2 points to graph this one. Okay. And then 0, and then when x is 1, y is negative 1. So the 1 here, negative 1 here, right? So it will be right here. And I need to use the circle because I don't have an equal sign. The second one, when x is 0, y is this 0, this y equal to 1. So this one is a solid one because x can be equal to 0. 0 is less than 1. And since the x had to be less than 1, so go all the way to the left. So this is how you look at that. Okay, so that's one piece. All right, I cannot draw for anything down here because if I draw for the button here, x will be greater than 1. Okay, so that is how you draw for the first one right here. And then you can draw for the second one, same thing. X, and then this y will be equal to x minus 1. Okay, but this x has to be greater than or equal to 1. So now this one x can be 1, and 1 will be a solid one because this has an equal sign. 1 minus 1 will be 0. Okay, and x can be 2, 2 minus 1 will be 1. So the second one, I'm not using the right one. Okay, when x equal to 1, y will be 0. Okay, so actually this will be right here. All right, and when this is 2, this is 1, so this will be right here. All right, and this will be a solid one. Okay, this will be solid one right here. So you can go to see which one look pretty much the same. The first one look pretty similar, but except the first one, for the less than using the solid dot. When you have an equal sign, you use the solid dot. When you don't have an equal sign, you have to use the circle. So this one is wrong because the first one right here, using the dot. The second one have an equal sign using the circle, so they just do the opposite way. All right. Otherwise, the shape look pretty similar. All right. And if you look at the second one right here, second one is even a wrong shape, right? Don't look alike. Okay. And of course, the third one is also the wrong shape. And there's another one right here should be the correct one. But the correct one will be similar to this one, but this will be the circle. This one will be solid. Okay. You can also put this one in a calculator to see how you look like. All right. I think a graph by hand is pretty straightforward, right? You only need 2 points. But if you really don't want to do that by hand, you can also do that in a calculator. Okay, so I'm showing you how to do it in a calculator. We're gonna clear everything in here. And then we're gonna using the first one, 1 minus 2x. Okay, and the problem is when you graph, this one will go all the way because default is graphing all the x value. So there's a trick here. If you don't want them to graph the whole thing, you can put a condition here. Okay, so this is a little bit a calculator trick. You can use the divide sign and then put a parenthesis and then set up the condition here. Okay. And then we will need to go to find the less than. So second math, the one you can come in here, find the less than 1. Okay, so now this will be the same as the first one right here. When I graph, what happened? It stopped right here. Okay, it stopped right here. All right. And same thing as the y2, right? So y2 here is x minus 1. Okay, and like I said, if I don't put a condition, this will be graph the whole x value. All right, and if you go to the second table, you can just pick whatever. Why this one got an error? Because this one now, y1 has an error in here because x can only be less than 1. Okay, so that's why this got error. And then when you go up, this will be do not have an error in here. Okay, so all you can calculate, you can graph the number here and then and then drop manually if you don't want to calculate by hand. All right. And same thing, we can put a condition in this one. So using a divide sign, parenthesis x, right? And then this one is greater than or equal to 1. So go to the test here. Greater than or equal to 1 is number 4. Okay. And don't forget, you need to close the parenthesis for the condition to meet. All right, so when I graph now, it will look like that. Okay, and you can zoom in, zoom out pretty, a little bit clear, that one. Okay, so if you can zoom in, zoom out, that one. And don't forget, this one don't look like a graph the solid and dot very clearly, right? So you will need to know the first one right here don't have an equal sign, so you need to use the circle. And the second one right here, the second one right here, you will need to use the solid dot because you have an equal sign. Okay. All right. So you can do that manually, or you can do that in a calculator. Okay. Second one right here, the following graph is a result of applying a sequence of transformation to the region of one of the 6 basic functions. Okay, so what is one of the 6 basic functions? square root square q loop q, y equal to x, y equal to absolute value of x. This is all the 6 basic function in here. And how does this one look like? This one look like if you learn this chapter, you will know this look like a x squared is the quadratic, right? Quadratic we use a lot. All right, so if you do not know, I can show you how to graph all this by hand. So y equal to x is the identity, is a straight line, right? So that's y equal to x, very, very easy, okay? And y equal to x squared, okay? So x squared, so now you can see this is how x squared look like, right? When the x squared coefficient is positive, it's facing up. If I have a negative x squared, what happens? It's facing down. Okay, so this will be facing down in here. All right, and cubic look like, let's see how the cubic look like. So x to the 3 power, that's the cubic. Okay, so you know cubic going to 2 different directions, right? So that's how the cubic look like. All right, so how about the square root? You want to use the square root, you need to hit second, right? So that is the square root. So that's how the square root look like in here, okay? All right, and then let's see how the Q loop would look like. Okay, if you don't have a Q loop in here, you can use x to the 3 power, 1/3 power, 1/3 power, that's the Q loop. Okay, so that's how the Q loop would look like. Or you can use this one, okay? You can use go to math, and then you can find a Q loop in here, okay? So that's the Q loop of x. All right, so they are the same, okay? So if you if you don't want to go to find that, you can just type 1/3 power, or the Q loop of x is the same thing. All right, so that's how you look at that. Okay, so we are kind of knowing how this look like right here, right? So now you know this look like the C. So this is the y equal to x squared. And sometimes people say, why this one y equals, but this one is moving down for 1 unit in here. Look at it. Moving down for 1 unit and also moving to the left. Okay. So moving to the left and also moving down for 1 unit, because this is 2 in here. So if I have a y equal to x squared, it looks like that. The vertex is in the origin in here. But if I have this one right here, x, this moving to the left, so it should be +1. And then square. Okay, so this is moving to the left. Look at it. Moving to the left for 1 unit, right? And then if I move down, okay, so if I have an x +1 square and then -1, so this will be moving to the left, 1 unit, also moving down for 1 unit. Okay, so I can zoom this one a little bit, so you can see a little, or I can reset the window. Okay, I can zoom to standard. All right, so you can see a little bit better in here. Okay, so the blue one is y equal to x squared, right? And the red one here is moving to the left for 1 unit, so y equal to x +1 squared. The black one here is moving to the left 1 unit and also down 1 unit. So that's the 3 equation in here. Okay, all right, so this is actually definitely, yeah, write out the equation for the given graph, right? So the graph here will be x +1 square and then -1 in here. All right. Okay, so this one right here is you want to find a vertex. Okay, I will let you have one-page formula sheet for this chapter test, okay? And one-page formula sheet, I think I will give it to you, I will post it on the Canvas. So what one-page formula sheet you can have for the test, all right? And you can either using completing the square method or you can using the formula method, okay? You have a two way to do this one right here. I know sometimes when you try the first class, you probably feel pretty foreign when you're trying to see this one. But after you do the homework, you will feel much better, okay? So you can have a two-way. The one way is completing the square. So what is completing the square method in here? If I have a f of x equal to a times x minus h squared plus k. If I can have a formula like that, my vertex here will be h and k. So that's why it asks you to complete a square to find the h and k. But in this one in here, I can complete a square, okay? So we're gonna have a x squared minus 10x, and I will need to add a number. I also need to minus a number in order to complete a square. So this we usually call adding a zero. Okay, so if I add a zero to this equation, it will be still the same as this one. So how do I add this one in order to complete a square? You're using 10 divided by 2 and then square them. So 10 divided by 2 will be what? 10 divided by 2 will be 5. Okay, so I need to add a 5 square. And then I need to minus the 5 square. So if I add a 5 square and minus the 5 square, the equation is still the same as the previous one because it's called adding a zero. So this one is considered a transform, right? Transform, but do not change the value in here. So I'm going to put these three together, it will be a completing a square. So these three I can write down as a perfect square as x minus 5 perfect square. Okay, and then these two, I just go to add them together. All right, so this is a negative 25 plus 99. Okay, so that will be plus what, 74. Okay, and then I compare to this one right here. My h here will be 5, right? So my k here will be 74. Okay, so this is my a here will be 1. We usually don't need to write down 1. That one. Okay, so my h here minus the h, so this is minus 5. So h here is 5. K here is 74. So this is the vertex. Okay, so that's called completing the square method. Actually, you can use the formula method. Okay, so what is the formula method? If my f of x is in ax squared plus bx plus c form, this is a standard quadratic equation formula, right? This is ax squared. And then I compare this one, my a here will be 1. My a here is 1, right? And my b here is what? My b here is negative 10, okay? And my c here is 99, all right? If you compare this formula to this equation, okay, you have a, b, c. And the formula here is the vertex formula. This formula actually is in the formula sheet, okay? So if you want to use this one, your vertex is using negative b over 2a. For the x, and then whatever this one right here, you can just calculate. You can just plug the x in. You can just plug this x in, plug this negative b over 2a in to calculate the y. Okay, so I can calculate this one for you. So my vertex x here will be negative b, or my h here, negative b, b here is negative 10. 2 times a here is 1, right? And negative, positive, so that's 5. Okay, so my vertex x here is 5. Look at it. It's the same thing as we just did here. The vertex x is 5. Look at it. And I can just using the negative b over 2a. I already found the 5. Okay, so how do I find my y for the vertex? I will just using this x value, which is equal to 5, plug it into the original one. Okay, so replace x by 5. So this will be 5 squared minus 10 times 5 plus 99. All right, and then we just go to calculate this one. So 5 squared is 25, 25 minus 15, negative 25, negative 25 plus 99, so 74. Yeah, so you got exactly the same answer. All right, so that is using the formula. And of course, I said earlier, this formula is in the formula sheet. Okay, so if you want to use this formula, you don't have to complete the square. All right, so either way, even if it's a complete square, you can still using this formula to do if you want to. Okay, or if this one asks you to completing the square, you can just come back here, write down x minus 5 squared and then plus 75. You can use that one and write down this form. All right. Any questions? Okay, write down the equation for the graph in this form. A will be either 1 or -1, and then basically you want to write down this one in a equation. You want to plug a and h and k in, okay, and then keep the same equation in here. So how do we do this one? You can enlarge this one, on the test, you can, do the homework, you can enlarge this one very, very good. Oh, hold on. They're too big. Which question are we doing? We're doing number 9, right? Number 9. Yeah, this one. Okay, so I'm trying to get this one really big. Yeah, on the test that you can just enlarge this one, but I'm not on the I'm not on the live one, so I'm trying to get this one, trying to see on the big one. Okay, all right, so that's good enough to see, right? So you can see this vertex here, of course, this is gonna be -1, A gonna be -1 because this is facing down, right? Parabola facing down, the coefficient of the coefficient of A will be negative. So A is -1, right? And then we're gonna find the H. H is moving on the X direction, so you're moving to the left in here. So that's 1, 2, right? So moving to the left. So this one is left 2 and then up 5. Okay. So we have this one here is left 2 up 5. Okay. And then A here is -1. So my f of x will be -1. Okay. And then this will be h squared. Up 5 will be +5 at the very end. Okay, and therefore 2, you're gonna using the minus a -1 or +2, minus a negative or remember x here, the plus is moving to the left. Okay, a little bit opposite than the outside. The outside up positive is 5. Okay. All right, so that is the answer in here. This is negative, and then x +2 squared +5. If you do not know, you can after you do this one, you can graph to see if we look similar like this one, right? So we can use a calculator to double check. Look at it. All right. So we can use the calculator to double check this one. There's another way to double check. So I have a negative x +2 squared. Okay, +5. Okay, to see how graph does that look at the graph we have. Yeah, look pretty similar, right? Look pretty similar to the one we have here. All right, so you can see, yeah, look pretty similar. All right, so that's another way, after you write it, if you're not sure to see, if you look good or not, you can now you've got an equation you can graph. Okay. Number 10 here. What is the maximum number of the x-intercept of a polynomial of the degree 14 can have? Okay, so the maximum number of the x-intercept is the same as the polynomial degree. Okay, so if you have a degree of the 14, the maximum x-intercept of the polynomial will be 14. So that's really easy, right? So look at this one right here. If I have a quadratic, which is power of 2, right? The most x-intercept I can have is 2. Look at that. This is a quadratic. It's a power of 2. So the most I can have is 2. If I only have a y equal to x, like I say, x plus 3 is a linear. Linear is power of 1. So power of the 1, the x-intercept is passing the x-axis. Let's call it x-intercept. If it's a linear, the x-intercept is only 1. The maximum is only 1. Okay, and the parabola, the x squared maximum, you can have a maximum or you don't have a, you can have only x squared plus 2. Hold on. Okay, so look at this one right here. My blue one, I actually only have only one x-intercept because this vertex is on the origin in here. So the blue one only cross the x-axis once, okay? But the red one, you cross the x-axis twice, all right? So you can have 2 or less, but you cannot have more than 2 if the degree is 2, okay? So this one is at a maximum number. Maximum number of the x-intercept for the polynomial is the same as the degree. So that's 14. Yeah, exactly. All right. You can have a 14 or less, but you cannot have anything more than 14. So that should be easy. It's just a concept. Okay, number 11, find the equation of any vertical asymptote for the function. So what is a vertical asymptote? Vertical asymptote is the graph cannot pass. Okay, so this one we have to do a little bit factoring. That's why I in the homework assignment you have a little bit section called factoring because you need to have a factoring in order to do this one right here, right? So how do I factor this one? Okay, as long as you do the factoring, this should be pretty straightforward actually. All right, so we factor the common factor out, right? So the numerator, you have an x, so we're gonna take the x out. So this will be x plus 5, okay? And the denominator, you also have an x, so we also factor x out. So if you factor x out, this will be only x squared minus 36, okay? And these x and x cancel out. So this cancel out cannot be a vertical asymptote. All right. So the vertical asymptote is on the denominator equal to 0, but you don't have a common factor. So this common factor actually create a hole. Yeah, the graph will have a hole at x equal to 0. But this hole is not a vertical asymptote. All right. So when we have a squared minus b squared, we can factor into a plus b times a minus b. Okay, so this is the factoring formula. You will need to keep it in mind. So x squared minus 36, I can write down as x squared minus 6 squared. So that means I can factor this one into x plus 6 times x minus 6. Okay. All right, so now we don't have a common factor with the numerator anymore, right? So when the denominator equal to 0, which is each factor equal to 0, all right, each factor equal to 0, and then we solve for x. So x here will be x equal to 6. X here equal to -6 for this one. If you solve this one, x will be -6. If you solve this one, x will be 6, right? So these two will be the vertical asymptote. Okay, so that means the graph cannot pass these two vertical lines. All right, and you usually vertical asymptote is a line, so you need to write down as an equation. So you will need to, this one has a 2 vertical asymptote. All right, the leftmost, you have to be very careful. You have to say which one is the leftmost asymptote, which one is the rightmost asymptote right here, right? Leftmost, rightmost. So you also have to write down in the correct way. So leftmost will be on the left side vertical asymptote. Okay, so if you have a x equal to -6 will be on the left. Okay, so if you go to graph this whole thing in here, right? And then -6 will be on the left, +6 will be on the right. Okay, and then the vertical asymptote we usually using the solid the dotted line, not using the solid line because it's not part of the graph, but will help us to graph this one to see how this look like, you know, in a coordinate. So the leftmost vertical asymptote will be, this will be the left, right? This is the right. Okay, so that's the vertical asymptote. All right, so we're almost there. Actually, the test is only 15 questions, okay? The reason we take a little bit longer time because we're trying to explain everything related to the concept here, all right? Number 12 actually is pretty similar, okay? Write the equation for the lowest degree polynomial function with the graph showing the in here, right? An intercept with this graph for the exercise, making the leading coefficient is +1 or -1. This one is very similar to the one we just did earlier, except this time this A will be +1 because it's facing up, right? So this looks like a parabola. Okay, so parabola, the x square we use the most. All right, so this one, it looks like a I cannot really find a vertex in here because this vertex is not an integer. Okay, so I do have a x-intercept here is the integer in here. Okay, so what does that mean? That means this one I cannot use this way to write down. I cannot use the vertex to write down that one. Okay, I'm gonna have to use my general equation. So the difference here of this one is a little bit different. The technique will be a little bit different. I need to using the f of x. Okay. I'm trying to erase this one. All right, I'm gonna using the f of x equal to ax squared, which is 1x squared. This using the ax squared plus bx plus c. Okay, and then I just need to go to find my ABC, and we already know this one is using the A here will be +1 because it's facing up. So this will be just x squared plus bx plus c. So the only thing I have to find here is two numbers, b and c. All right, so if I have a two equation, I can find these two numbers easily, right? And then let's see, since we cannot find a vertex because this vertex is not right here, but this is right here in the middle. So since in the middle is a fraction, so it's very hard to estimate how much is there. But at least we know the vertex here looks like in fourth quadrant. So x will be positive, y will be negative, right? But if you go to look at this one right here, I have a very clear x-intercept and clear y-intercept. Okay, using the graph or an intercept showing. So that means you want to using the intercept to solve. Okay, all right. So I have a clear x-intercept here when y equal to 0. Okay, y equal to 0. X-intercept, right? This one is 1, 2. Okay, so my y equal to 0. One of them is x equal to 2. One of them is x equal to -1. Okay. All right. So if I have a 2, this will be 4 plus 2x. Oh, I'm sorry. That's for the x. B is unknown, so that's 2b plus c. Okay, so that's when x equal to 2, y will be 0, right? This point y here is 0, x-intercept. Another one here is y is also 0, but x will be -1. So -1 here, negative square will be still 1, but this will be minus b plus c. All right, so now we can solve for this one. Actually, you can also using the when x is 0, y is what? Y is 1, 2, y is -2. So when x is 0, y is -2. You can use this one actually easily to solve. Okay, so when x is 0, y is -2. So that means c will be -2. Look at it. This one I can solve for c easily. When y is -2, this is -2, x is 0. So c is -2, right? And then if you solve for c, you can find a b easily. Okay, so this one it give you more than what you need here. So you can plug either this one or this one to find a b. Okay. All right, so if I put it into this one, I can find a b, right? So my 0 here will be 1 minus b plus c here is -2. Okay, so if I add a b on both sides, this b here will be 1 minus 2 here will be -1. Okay, all right, so my f of x here, just plug it in. My f of x will be x squared, right? X squared plus bx. B here is -1, so that's x. And then c here is -2. So that's my equation. Okay, that is the whole equation in here. And if you do not know, you can go to put this one in a calculator graph to see how you look at that. So you can use the graph to double check you final answer actually. All right, we can plug it in and then we can plug this whole thing in a calculator, right? And let's see what we got. We got x squared minus x squared, minus x minus 2 in here, right? So let's see how you look at that. Oh yeah, looks like pretty similar to the one we have, right? Pretty similar to the one we have, very similar, okay? So that is how you check your answer. You can use the graph to actually double check your answer, okay? Write down the equation in a polynomial function. So yeah, this is the polynomial form, right? Polynomial is ax squared plus bx plus c, okay? All right, number 13, this is just for your exercise only, okay? Solve the given equation for the x, okay? All right, so how do we solve this one right here? Hold on, I run out the pages. Okay. Let me make a new one. Okay, so number 13 here, you can factor it out. Look at it. You can factor this one out, right? You have an e to the negative x. So you can just pull this whole thing out. So you're going to have an x minus 4 equal to 0. Okay. All right. So one thing you need to know here is e to the negative x never go to 0. Okay. This is called a exponential equation. Later on, we will learn. But the e to the negative x never go to 0. So the only thing can be 0 here is x minus 4 equal to 0. And you go to solve for x. So the only thing this one can be 0 is x equal to 4. Okay. All right. So it's only one answer. So actually it's pretty easy, right? If you know the concept, e to the negative x won't be 0. Okay. This number 14 here, we do learn a little bit logarithm equation, okay? So what is a logarithm? Logarithm here is, you want to write down this one into the logarithm. So you have a to the x, right? So if I have a a to, hold on. If I have a to the x equal to y, okay? So this X here is the exponent. I want to write down the log. So this is equivalent to this one. The base is the base. The base in the exponential equation is also the base in the log. Okay, and the exponent is the logarithm, which is going to the right side. All right, and then this y here will be going here. Okay, so if you remember this one right here, and then you will know how to convert this one into log, right? So if you write down 6 to the 3 power equal to 216, now you can just convert this one. My a here will be what? My a here is 6. So this is log 6, okay? And remember the power is going to the right-hand side. All right, so the base, this is a base, and this is called a base. Okay, base stay the same. Base in the exponential and the logarithm is also the base. All right, and the exponent is logarithm, so exponent going to the right side, and then this 216 is going here. You only have a 3 number. If you finalize the 2, the third one will be easy, right? If you want to convert, if you given you this logarithm, you want to convert it into exponential, it just drop a little bit circle. Just like that, drop a little bit circle. So 6 raised to the power of 3. 6 raised power of 3 will equal to 216. Look at that. So these two are, this is get rid of the log, right? So now you're back to this one in here. Okay. All right. So that is how you write down in a logarithm form. Okay. And how do you solve this equation in a logarithm equation in here? Okay. As I mentioned earlier, you can convert this one into a log equation. E to the x equal to 5.414, right? You can convert this one into a log. So my base here will be E. My base here will be E. E. And then this exponent going to the right-hand side. Okay, and then this will be 5.415. Sorry, this is not quite. Okay. Let me erase this one, write down a little bit easier reading for me. Okay, this whole thing equal to x, right? So e to the x power, if you convert the e to the x power, will equal to 5.451. All right, so if you have a base is e, we usually using a symbol using ln to represent 5.415 equal to x. So where do I find this one right here? You can use the calculator. This one you definitely need a calculator in order to find this logarithm equation. Okay. All right. So the logarithm equation here, ln is base e. Look at that. So this is just ln 5.451. Okay, and then round to 4 decimal points. So now you just convert the 4 decimal point. 1, 2, 3, 4, right? So 1.6958. The reason you need to have a last digit is 8 because the next digit is 9, so you need to round up. So you need to keep the 4 decimal point. You need to keep the 1.6957, and then look at the next digit. Next digit is 5 or above. You round up. Okay, so your x here is 1.69. 969, 1.6958. Okay, because you need to keep 4 decimal point and then look at next digit round up. All right, and that's it. That's the whole equation. That's the whole review. So that is how your test review gonna look like. I know this is your first test. You will have to go through all the detail in order to get to this point, right? So for some of you, you might feel a lot at the beginning because you haven't started a course yet, okay? And I do find some people already start a course, a little bit earlier, which is fun, all right? When I go to the Gradebook, I already see some people already start a course, which is really good. All right, if you don't, today is the 4th day, so you definitely need to keep up with the schedule, okay? All right, so that's all I have. I'm gonna stop the recording and I will let you ask any question you might have, okay? Or one-on-one question, whatever you have. So I'm gonna stop the recording.